What is the evidence for reopening brain critical periods? Imagine your brain as a busy city with certain neighborhoods open for construction and change only during specific times. These times are called critical periods, and they shape how we learn and develop. Now, scientists are asking if it's possible to open these neighborhoods again after they've closed. The answer is yes, and the evidence is quite fascinating. Research shows that critical periods are driven by biological changes in the brain. During early childhood, the brain is very flexible because of high levels of certain chemicals and structures. As the brain matures, these factors change, making it harder to rewire or learn new skills. But scientists have found ways to influence these biological factors. One way is by reducing the activity of a chemical called gamma-aminobutyric acid, or GABA. GABA helps slow down brain activity, so lowering it can make the brain more plastic again. In experiments with adult animals, lowering GABA levels has allowed them to regain some of the flexibility they had during early development. This means they could recover visual functions after deprivation, like when one eye was covered during childhood. Another method involves breaking down structures called paraneuronal nets. These nets are like scaffolding around neurons that help stabilize circuits and limit plasticity. When scientists enzymatically digest these nets in animal models, the brain becomes more adaptable. This can lead to rewiring of neural circuits that were previously fixed. Environmental factors also play a role. Providing enriched environments with varied sensory experiences or specific training can promote plasticity even in older brains. Some drugs have been tested that boost brain plasticity, showing that the window for change isn't completely shut after the early years. Early interventions during natural critical periods are especially effective. For example, therapies for children with developmental delays or autism are more successful when applied during these windows of heightened plasticity. This suggests that if we understand how to reopen or extend these periods, we can help more children reach their full potential. All this evidence points to the fact that biological mechanisms controlling plasticity can be influenced. By doing so, we can create opportunities for learning, recovery, and growth well beyond the initial critical periods. It's like finding ways to turn the construction zones back on in parts of the brain that seemed closed forever.